Okay, so this video is on radioactivity and the three types of ionizing radiation. So first of all, we're just going to describe why we have radioactivity. So basically, radioactivity comes from unstable isotopes, and unstable isotopes are decaying to become more stable. So just as a little recap, remember that an unstable isotope has an imbalance of those protons and neutrons, okay? So we might have too many protons, too many neutrons. It doesn't fit on that NZ stability curve, okay? So we've got an imbalance between those, and they are going to decay to become more stable. So the reason how they do this is they do this by the emission of radiations. That's what radioactivity is, okay, from the nuclei. So this might be our nucleus. So from here, they're going to emit some sort of radiation, okay? So we're only dealing with the nuclei in this case. So again, radioactivity is the emission of radiation from an unstable nuclei to become more stable. The big thing about this is that radioactive decay is random. Okay, so by random, that means I can't predict which nuclei. So remember, this might be just one nucleus, but in a substance, we're going to have billions, millions of nucleus. So we don't know which nuclei is going to decay. And we also don't know when it's going to decay. Okay, so it's random. I don't know which one's going to decay, and I don't know when it's going to decay. The other thing is that it's spontaneous. Okay, it doesn't have external factors affecting it. Okay, it just decays. All right, I don't have to heat it up and it decays more. I don't start adding more pressure and it decays more. It is a spontaneous decay. Okay, so spontaneous is it's not affected. Oh, I should say not affected by other factors. Okay, it has no other influences. So we then come on to our three types of ionizing radiation. So when we're going through this radioactive decay, it's decaying and releasing something from the nucleus. So in this case, we have three types. We have alpha, beta, and gamma. Now, if the nucleus releases an alpha particle, okay, an alpha particle is basically a helium nucleus, okay? So that means it's made up of 2 protons and 2 neutrons, okay? So 2 protons and 2 neutrons, all right? A beta particle is a fast-moving electron. If you go on to study at diploma level, you'll actually learn that there's other things as well. So we can have like an opposite of an electron, something called a positron. But in this case, we're going to talk just about the fast-moving electron. That's called beta minus. So it's a high-energy electron. Okay, so high-energy electron. So these two are both particles. Now, beta is the release of an electron. You might be thinking, where does an electron come from? The nucleus. Electrons don't exist in the nucleus. It's actually a different thing that happens there. Okay, in this case, we actually have a neutron, and the neutron turns into a proton, and to balance that charge out with the proton there, an electron is also emitted. Okay, so it's actually a little change that happens in that nucleus. Gamma is not a particle, it's a wave, and it's a high frequency wave. Now, because it's high frequency, it also means it's high energy, because frequency and energy are related. Okay, they are proportional to each other. Again, you're not going to have to learn this at grade 9, but they are related through this equation, E is equal to HF, which you will do again if you do diploma. So these are the three types of ionizing radiation. We have alpha, which is a helium nucleus, so 2 protons and 2 neutrons. Okay, so they have a positive charge of +2. Okay, so their charge is +2. A beta particle is just a fast-moving electron. Okay, actually what's happening in the nucleus is a neutron turning into a proton, but you don't need to tell about that. And in this case, we also say the charge is -1. Gamma is not a particle, it's a wave. So in this case, it's high frequency and high energy. So it has no charge. Its charge is equal to 0. So the next thing that we could talk about is the differences between these. So one of the main differences that we have are actually how far they can penetrate, so how far they can travel through air or what materials stop them. So if we go through these different examples, alpha can't actually travel very far in air. In air, alpha only travels from about 5 centimeters before it doesn't continue. Okay, it's stopped by paper, it's also stopped by skin, so it doesn't go through your skin. beta can penetrate a little bit further, okay? So we can say between like 15 to 50 centimeters in air, but it's stopped by aluminium. Okay, so if I was trying to contain beta, I would need to put it in an aluminium casing. Gamma can go the furthest. Okay, gamma is actually got an infinite range in air. Okay, and it's stopped by lead, or I should really say thick lead. Okay, it has to be really thick, or also thick concrete. Okay, so we often have lead-lined cases when we're containing sources that will give us gamma rays. Okay, so again, we talked about the differences there. So we've got their penetration lengths. So alpha is the least penetrating, so it means it can go the least amount of distance, and gamma is the most penetrating. Now, because of that, that actually means that alpha is the most ionizing, and gamma is the least ionizing. Okay, and that's because over alpha, the energy that it's got has only been distributed over a small amount of space, so therefore it's really highly ionizing. It's got a lot of energy. I haven't gone over what ionizing means, I'll go over that in a second. And gamma is the most penetrating because its energy is not being lost and it's being travelled over a very long distance. So yeah, we call these ionizing radiation, and we talk about what does ionizing mean. So I'm just going to jump back here. Sorry, I just missed off the bottom of my page there. Ionizing means it removes electrons. Okay, so remember, ions that form are lost electrons. So what this means in terms of your like human body, if we've got like your skin, for example, here, okay, your skin is made up of cells, the cells are made up of atoms, okay, and without ionizing those atoms, what we're doing is we're changing the cell, so the cells can become damaged, okay. They could also cause mutations of those cells, and if we got enough mutations, that could build up into a tumour, which could cause cancer. Or if again we have so much damage and so much ionizing happening to the cells might even die. Okay, so in terms of the danger of ionizing radiation, okay, ionizing is affecting the atoms, which in effect also changes the cells. So the cells can become damaged, they could die, they could mutate, which can lead to cancer. Okay, so again, thinking about that energy there, the ones that are the most ionizing are alpha, because their energy is only distributed over a small distance, whereas gamma, okay, they are the least ionizing because their energy is transmitted over a longer distance. In terms of then like kind of danger to your body, it's actually really dangerous to consume or get alpha inside you, okay, because alpha cannot get out or past skin, so it would be stuck inside your body, whereas gamma, which we use in medical traces, we'll talk about uses of radiation, gamma can get outside your body. So when you're dealing with radiation in hospitals, you're often dealing with gamma, so it can get through your skin. And that's radioactivity and ionizing